I'm Kristen Beam, and I'm going to be doing my Fundamentals of Physics podcast on surface tension of water. And I'm going to be using water, a bowl, and some pepper. It's going to be really exciting. You guys are excited. Oh my god, it's going to be so cool. You ready for this? Nope, no, you're not. Alright, so here I have my bowl of water, skin, still completely intact. And the skin is caused by the polarity of the water, pretty much the or the positive hydrogen molecules and the negative oxygen molecules, which attract each other and cause this skin. Now, the molecules at the top of the surface they pull against each other in fewer directions than the molecules in the middle of the liquid, because obviously it's a surface, so it doesn't have all this space around to still pull. So because there's air on top of it, the air molecules are pushing down on it. It only has so many directions it can pull. So because it has fewer directions, it bonds more strongly in those directions than the ones in the middle, which are more balanced out because they can pull in all directions. So what's going to happen is I'm going to put some pepper on the top of the bowl, and this the surface tension of the water should support the pepper. And then I'm going to put a little bit of detergent on my finger, and I'm going to put it into the water, breaking the surface, and the detergent should pull away that skin, should destroy that skin completely, and the the pepper will be attracted to the molecules of the detergent, and it will pretty much just follow it to the other side of the bowl. So that's what should happen, so let's watch it in action. Okay, so I'm going to put some pepper in the bowl, like so. Coat the top pretty good so you can really see what's going on. And it all stays pretty much afloat, except for a few that won't. And then I'm going to get some detergent on some dish detergent on my finger. Oops. Like so. And then I am going to stick it into the bowl of pepper. And it all moves to the other side because it's attracted to the molecules of the detergent. And you probably couldn't see it, but there was actually, you could see the skin break. It was really interesting. But yeah, so that's what happens. Alright, so what I've just shown you is really just an example of actually more of the strength of the skin that's on top of water. And also the polarity of the detergent molecules, because the detergent molecules only have a partially charged polar end and an uncharged nonpolar end. So it's kind of weird when it works, but when it's put into the center of the bowl, the nonpolar pepper molecules they're attracted to it. They're more strongly attracted to nonpolar than they are to the water polar molecules, and they kind of just ride it across the bowl. So it'll spread out pretty rapidly throughout the bowl, and once it does, later the pepper molecules will probably end up spreading back over the surface of the water, which will now be actually detergent, because it's kind of reformed another layer. So the water molecules are one positively charged end and one negatively charged end. Positive charge on the hydrogen and a negative charge on the oxygen, and they attract each other, and as well as hydrogen bonds, which also help reinforce the skin on the water. And it doesn't do this in the middle because the water molecules in the middle will be pulling in all directions as opposed to just the few directions that it is pulling on the top, which make it stronger. So, yeah, that's what I've shown today. Hope you were thoroughly entertained.